Oh my heavens!
I'm at the Streets factory in southwest Sydney.
Man, this just goes on forever. And of course there's beautiful stainless steel, and there's robots, and there's conveyor belts. It's just moving so fast. How many ice creams or serves do you push out each day here?
The site will make around 3 million servings per day.
3 million?
3 million.
It's made possible by the blending of modern food science with the latest in high-tech machinery.
I can see a little laser pointer down there. I'm guessing it's checking that each slab of ice cream has a stick in it?
Yes, that's correct. We have a lot of advanced automation to handle the product. We're trying to make sure that no human hands touch the product to ensure the highest quality standards that we have.
Today on the production line, they'll be making two very different ice creams. One, a choc-coated vanilla Magnum. And the other, a two-tone caramel biscuit-covered Aussie creation, the Golden Gay Time. It all starts in the mixing room with a super-sized blender.
This stainless steel mixer can take 6 tons.
6 ton mix.
But it's all...
And we can pump out around 14,000 litres in 1 hour.
Cass has 20 years' experience in ice cream manufacturing and is something of a human mix master.
Oh, hang on. Now, what are they adding here?
Skim milk powder.
I've never seen that being used. Vacuum assist for lifting, but it makes so much sense. And I noticed that the inside of the packet seems to have a plastic layer, so it will also provide air resistance, so that way you get good vacuum suck. Can you show me how to do that? Is that possible?
I need to teach you how to do that.
Yep.
This is up.
That activates the suck.
Yeah. You just put this.
Ah, you're kidding. Okay, put it down again. Can I do that one? And then
On it, yeah.
put it down here. Is that right? I put it on there. And I squeeze. Oh my God. Let go.
I'm going to pull it down and slide down.
I love this machine. I mean, 25 kilos.
Yeah, take your groceries up there.
If I explain the science of ice cream, one is we call it ice content, which comes from water when you freeze it down. Second is the fat, which comes from cream, and butter, which we use in our product.
Next, stabilisers and emulsifiers are added for structure, together with a bit of sugar.
Sugar play a very, very important role in terms of the sweetness, and it also gives a certain body. And the most important element is aeration to make it more smooth in terms of mouthfeel and texture. Without air, it's a block of ice. So when you add air with the combination of sugars and ingredients, it's easier to eat, the mouthfeel is more creamier, and that's what ice cream is all about.
The secret is to mix them in the correct sequence to form the chemical structures that make ice cream. One misstep and the batch is unusable. For the rich, creamy centre of our choc-covered bar, there's still one key ingredient to be added: vanilla flavouring.
Now, I notice now I'm beginning on the top to see a sort of a yellow
you can
colour.
see what's happening right now. Water and fat, they don't mix together. They don't mix together. Why? Because water is a polar molecule and fat is organic molecule.
So the fat repels.
Fat is added to the recipe, not just to enhance and carry flavours, but it also stops the mixture from becoming icy too soon.
The fat is trying to be dispersed. So what we do, after this, we will send it to homogenizer. And homogenizer is a very, very important part of the mix processing plant. We call them the beating heart of the factory.
Rather than cooling down, here's where things heat up under pressure.
Oh my heavens, this is noisy.
So we are usually preparing a mix at around 65 to 70 degrees centigrade.
Warm.
Homogenising further breaks down large fat globules into tiny uniform particles, creating a smoother, richer texture.
So this is homogenizer and factorizer. This plays a very important role for fat particle size distribution. This is a pump which basically forces the fat particle through a very small orifice, and the amount of velocity it creates, which is almost equal to 12 to 13 kilometers per second.
Wow.
It is the same velocity required for the rocket to escape from the Earth's surface. So that's happening inside that homogenizer.
Looking at this stuff here, it's like fully...
Time to head upstairs, where they take the creamy mixtures to the next stage. And here's something I never thought I would see in an ice cream factory.
So we call this the aging tank farm. This
Aging?
is where the fats and oils then start to solidify and form crystals.
Like wine and cheese, apparently ice cream needs to age.
Normally the process is about a couple of hours, but it can be up to 12 plus hours. This is enough time to give the mix a chance to age correctly right before it goes to the freezer.
What if you don't do the aging? What happens?
If you don't do the aging, the ice cream is less stable. So it's more likely to sort of fall apart. It won't hold its structure as well. So that's why the aging process is so important.
From the tank farm upstairs, the aged vanilla thick shake-like mixture comes downstairs via some lovely stainless steel. And when I say this is the cool part, I mean really cool.
Oh my God, that whole cylinder's covered with ice. What's going on? Why is it so cold?
Yeah, so basically what we're doing now is we're converting the mix into ice cream.
Inside, the liquid is rapidly frozen, going from around plus 4 degrees Celsius down to around minus 8 degrees.
So as the mix comes through, it spends about 10 to 15 seconds in a continuous process going from the back to the front as it gets pushed out.
Wow, and in that time, 10 to 15 seconds, it can freeze.
Yeah, so
Wow.
it needs to be quite fast because you need to control the formation of the ice crystal and the size to create the consistency that you want within the ice cream. The mix freezes on the outside, and then we have a dasher which scrapes the outside with the
Wow.
ice crystals off. As part of that process, the air gets mixed in, and that's how we actually form ice cream.
You're adding air, you're cooling it, you're doing physics, chemistry, and thermodynamics all at the same time.
It's very cool.
Oh man, you got complexities on complexities.
So as the ice cream moves through, it'll get pumped across, over above us, and into the line. So then comes down through, and it goes through an extrusion head, and that extrusion head is what forms the iconic shape. So when you pick it up, you'll always get the same shape.
So how long can we leave it like this when it's not fully frozen because it's only at -5 or -4 or something?
It goes straight into our freezing tunnel, which is right behind you.
Oh my God, is that a freezing tunnel?
Yeah, that's right.
More than 10 tons of chocolate is melted here each day, after which it goes to the dipping station.
Yes, that's a really cool part of the process. You need to make sure the ice cream has enough cold energy in it, so once it goes into the chocolate, it actually will harden and freeze the chocolate. The ice cream doesn't have time to melt. It freezes the chocolate.
Wow, so that way you maintain the structural integrity of the ice cream. How clever.
It's time to put the finishing touches to our other frosty toffee dessert. It's here that biscuit meets bar.
Now this is our vanilla flavoured coating crumb.
Really?
This is from a local supplier. It's manufactured and made as a biscuit.
Yep.
And then it goes through a crushing process.
Exactly how the biscuit crumbs stick to the outside of the chocolate, well, that's top secret, so I can't tell you. But I can give it a personal munch.
Wow.
All that is left is to package them up and get them out the door.